Hello, and welcome to my DockerCon 2022 breakout session, Developer Environments in Docker. My name is Kris Rivera, and I'll be showing you what we've accomplished and what we envision achieving at Inside Cloud Security at Rapid7. But first, a little bit about me. I am a principal software engineer at Rapid7. I have been working at Inside Cloud Security for 3 years, but I have been working as a software developer for over 14. I like to read science fiction and fantasy novels, play video games, and code in my free time. As for my outdoor activities, I enjoy exercising, playing sports, and as a proud Latino, I love salsa dancing. The agenda for this breakout session is as follows. We'll go over a brief introduction of Rapid7 and Inside Cloud Security, followed by the goals we've set forth as an engineering practice. Next, we'll review the unique use cases around automation we have with Docker. Then, we'll do a deep dive into the main topic of this session, developer environments in Docker, where I will be giving you a detailed history, analysis, and code examples for being able to build a Docker development environment of your own. Finally, I'll show you the overall results of our efforts and what's next for Inside Cloud Security. So, as an introduction, Rapid7 is a Boston-based provider of security analytics and automation solutions, enabling organizations to implement an active approach to cybersecurity. In general, Rapid7 helps organizations innovate and accelerate securely. Over 10,000 customers rely on Rapid7 technology, services, and research to improve security outcomes and securely advance their organizations. With Inside Cloud Security, or Inside Cloud Sec for short, we enable you to drive innovation through continuous security and compliance, all in the cloud. Across all of our practices within Inside Cloud Sec, we use Docker in various ways. Our goal is to automate as much of our manual processes, such that cumbersome and time-consuming tasks take significantly less time. Producing faster builds enables us to regularly release versions of our software to our customers while also allowing us to adapt to security issues much faster. Currently, we ship release builds on a weekly basis, but attempting to get our builds down to a daily cadence would help us focus on improving all of the automation upon which we rely so heavily, while also staying ahead of security threats. This means we need to focus on increasing the predictability and velocity of our builds while also maintaining their quality. The way we are achieving this goal is by using Docker wherever possible, starting with development, supporting sales, providing testing environments for our user experience and quality assurance teams, and ending with production services being able to rely on Docker-enabled automation as much as possible. Production services uses Docker to build and deploy Docker images to Docker Hub for our customers that require an on-prem solution. They also deploy Docker images to AWS's ECR for our SaaS-based customers. Our latest releases are deployed internally where Rapid7 teams are able to use dog food deployments while our sales team demos our software from a dedicated sales environment. The UX and QA teams have custom ephemeral environments where they can deploy builds of active Git branches to verify any code changes before they are merged to our main development branch. Any code changes pushed to a GitHub pull request are automatically built and rigorously tested for code quality, compilation errors, and code formatting issues. On a periodic basis, the latest development branch has long-running integration tests run against it in a Docker environment, and the results are sent to a dedicated testing Slack channel. Our development team uses Docker as a development environment. We use Docker, Docker CLI, Docker Compose, Docker Desktop, and shell scripts to create an extremely unique and robust development environment that runs in Docker. This environment can be used to spin up any part of our development environment, whether to simply compile front-end assets, start our cache and database servers, run the backend in several configurations, or to start up the entire application in development or production modes, all with a single configurable command. We achieve this by performing a Docker in Docker technique of mounting the Docker socket inside of the running containers and using Docker's ability to commit layers to the base image after dependencies have been updated or installed. The shell scripts export required environment variables and run specific processes in the right order, while we use Docker Compose to ensure the appropriate service containers and dependencies are all running. Ooh, that was a mouthful. But let's take a deeper dive into the main part of this breakout session: developer environments in Docker. Back in January of 2019, before DivvyCloud was acquired by Rapid7, I started as DivvyCloud's first dedicated front-end developer. Like any developer, I was presented with the developer documentation. But unlike my previous jobs, I didn't want to simply follow the documentation. I knew that doing so would be time-consuming and potentially prone to error during initial setup. Instead, I started writing a Docker file with all of the steps from the dev docs. This way, if I didn't follow a step correctly, my host system would be left unaltered and any changes would be committed to a Docker image, which could be easily recreated. Admittedly, this did take me a bit longer than simply running through the docs, but I knew that this would be important for future developers who would be able to leverage automation while reducing the potential for errors. This was the beginning of our developer environment in Docker. As this single Docker image evolved into a more complex system, I quickly realized that I would not only need more Docker images, but I would need orchestration between the different running containers. This is when I introduced Docker Compose. Docker Compose simplified both building Docker images for each of our environments, but it also encouraged a high level of service separation. This meant that we were able to split out steps into well-defined service boundaries. In addition, we were able to reap the benefits of using Docker Compose for inter-container communication, private networks, mounting and creating Docker volumes, defining reusable environment variables and properties with anchors, and linking in containers for communication and aliasing. This was a real game changer for us because Docker Compose truly allowed me an unprecedented level of flexibility, which I pushed to many of its edges. Unfortunately, there's just one thing that Docker Compose did not allow us to do, and that was starting containers after a service or collection of services had completed their execution. This is where I needed to introduce scripting. Scripting was the last key to achieving what we needed while also adding another significant layer of flexibility. I was able to reduce many complex use cases and the need for any developer to know the intimate details of how and which services needed to be run down to a single command. When start sh is run, it also exports a whole host of environment variables, which configures the services in the Docker Compose file. Altogether, using Docker, Docker Compose, and scripting, I was able to develop a solution for our development team that could reliably replicate and work as a full-fledged development environment. But there is still more to do. We wanted to decrease the startup times past what Docker provides out of the box. Once the base Docker images are created, the bottom layers rarely have to change. So we essentially get that initial build time for free past initial startup. Even if we do have to make a change to the images, the cache layers make it a breeze to get through that process quickly, though it does come with a cost of having to reinstall all of the software dependencies from scratch again. But that is a one-time cost per each Docker image update. Committing the installed software dependencies back to the base image allows for a simple, incremental, and often skippable stage. The Docker image is always ready to be used for development and producing a production system, all on your development computer. Finally, I was able to enhance performance by skipping further steps and stages by capturing the checksum of certain files. If the sum did not change between Docker system startups, then that step could be skipped. All of these efficiencies put together reduce what was an already fast 15 minutes down to just 5 minutes. Wow, this has been truly impressive and allows any developer to get to developing faster. Here, you can see the general startup stages for our Docker development environment. The first stage is where the initial Docker images are built. The operating system dependencies and any source code dependencies are copied into the respective images and available for any subsequently created containers. Stage 2 is the software dependency stage, where the Python and Node.js containers will download all respective software dependencies for the first time. As with any first-time installation, this step takes a while to complete. Once they are complete, the layers are committed back to their respective Docker images and stored for future use. Stage 3 is our database initialization stage, where images for MySQL and Redis are built and any database table structures are created. Next, stage 4 is where any database migrations are executed and the front-end assets are built and stored in a statically accessible location for the web server. Finally, stage 5 is where the entire stack is started. All of our Python services begin to run and talk to each other, including the web server, the scheduler, and any number of asynchronous workers. But this is just the initialization workflow. The post-initialization workflow is reduced down to just 3 stages. These are the stages which need to occur every time we start up our developer environment, because that is what a developer would normally do after changing branches. They would ensure that they have the latest version of what is in their requirements text or package JSON. They would perform any necessary database migrations and build new front-end assets. And they would finally start all parts of the stack they needed to perform their job. This is where the most time is saved because we do not have to run any long processes anymore. Now, let's dive a little deeper and see some code examples and explanations about how to achieve this setup for yourself. An installation of Docker is required to be able to perform Docker in Docker. You can simply apt-get the Docker IO distribution as one of your first commands in your Docker file. Once the container is configured, we will ensure to mount the Docker socket from the host installation. As for mounting code and performing Docker in Docker itself, mounting your source code is insufficient without the :z property. This tells Docker that the content will be shared between containers. This then allows for mounting the same source code in both the front end and back end containers. The Docker socket from the host machine has to be mounted into the container so that any Docker operations performed inside of the container actually affect the host Docker images and installation. Without this, changes made in the container are only going to persist in the container until it is stopped and then removed. Committing changes as a layer to the base image is what drives the core of the developer environments in Docker. The container ID is first fetched based on the service name, and the changes made to the running container are committed to the desired image. Because the host Docker socket is mounted into the container, executing the Docker commit command, the container will affect change to the base image located in the host Docker installation. Once your services are set up in Docker Compose, you can start them all with either the Docker Compose up or start the individual service with the linked services with Docker Compose start web server. The linked services are also referenceable inside of the main container via the linked names. This makes it very easy to ensure that any environment variables referencing these services are overridden with the provided names. Starting a small part of the stack can also be useful if a developer only needs that portion. If we wanted to just start the MySQL service, you can achieve this with running Docker Compose start MySQL. Just as easily, you can stop the individual service by running Docker Compose stop MySQL. Because this service doesn't have any linked services, it will start up by itself. Mounting volumes into the database services allows for the containers to affect change to their respective databases while allowing the services to remain as ephemeral containers. In the main entry point and script orchestrator, we can simply provide a -p attribute to start.sh to set the prod build environment variable. As you can see, this variable is read inside of the build entry point and optionally builds a production or development version of Insight CloudSec. One of the issues we also had to tackle at Insight CloudSec was being able to attach a debugger to a running container. So, debugging inside of a running container can be just as easy as providing the appropriate debugging library in your mounted source code and opening a port to mount the debugger. In VS Code or your favorite code editor, you can provide a launch configuration to be able to attach your debugger on the provided port. Once the container is running, you can simply run the configuration and your debugger will be attached. Once the full stack is running, it is easy to access the main entry point web server via a browser on the defined web server port. You can also see the running containers by running the docker ps command. The containers are communicating with each other easily, all with the magic of Docker. Insight CloudSec is now running completely in Docker. All the code lives on the host computer, while changes are compiled and redeployed within the Docker containers. The development environment is now completely portable, but without having to install any software other than Docker. This is truly an amazing achievement. As a final digest of developer environments in Docker, you can see a list of pros and cons. We've already covered most of the pros, but there are a few cons that I have yet to mention. The first being that running your developer environment in Docker will have an additional resource overhead. Docker has to run, and it isn't for free. Also, if you're going to include multiple stages, which you likely will have to do, you will need to include scripting as a final orchestration layer. But as you can see, the pros heavily outweigh the cons. This has honestly been an amazing symphony of orchestration and engineering acumen to provide an extremely flexible and powerful environment for all of our engineers. Relying on the Docker toolchain has been truly beneficial for us, as this has allowed us to have a consistent environment in which to run any part of our application stack. Most impressively, what would often take days to set up your development environment simply takes 15 minutes to get completely up and running on your first day at Inside CloudSec. Docker has had an incredible impact on how we work on a daily basis and how our customers receive our software. From joining DivvyCloud in January of 2019 to being acquired in May of 2020 by Rapid7, to where our group has matured now, Docker has been an integral part of our journey and our evolution into the organization we are now. We are able to deploy extremely reliable software to advanced customer environments. We can analyze, review, and provide feedback on code before it is merged into development. We can ensure a much higher level of stability of our code base. What would normally take developers a minimum of a day or two has now been reduced to a 15-minute initial setup. Each developer has access to an extremely flexible and configurable development environment that, post-initialization, starts up in less than 5 minutes. None of this would have been possible without Docker. Rapid7 is better with Docker. Though we've accomplished so much to develop our processes around build, integration, environments, and deployments with Docker, at Rapid7, we are never done and continue to push the vision of what is possible. We went from an inconsistent build and deployment schedule to our current weekly build, but we want to do better. We want to deliver production-grade, stable builds on a daily basis, and we're confident that we can get there with Docker. Again, I'm Kris Rivera, and I'm so happy to have been able to take you on this journey using Docker. If you'd like to know more, please feel free to reach out directly to me on LinkedIn or on Twitter. Thank you.